Let us solve some of the problems in order to understand the state space variables as well as the state space model. Let us recall the basic concept. State model is nothing but x dot is equal to ax plus bu. So this is one of the equation which represents the state of the system. Another equation is there, y is equal to cx plus du. So these two are the equations combinedly called as state model. Whenever we want to derive an expression for a state model, first we need to find out what are the states of the system and what is the output of the system. We need to express the state in terms of ax plus bu and output in terms of cx plus du. And finally we have to calculate what is the matrix A, B and C, D. So here the differential equation is given. I will write the differential equation what they have given. So y triple dot is nothing but d cube y by dt cube plus 6 into d square y by dt square plus 11 into dy by dt plus 6y is equal to 2 into r of t. So here the input is given in terms of r of t. So this is a differential equation. Directly we can consider this itself, but for better understanding I have written this because you need to know how the output varies. Here the output is varies with respect to time. It is not dy by dx, it is dy by dt. To understand this I have written a differential equation. Let us assume state variables So you have to assume state variables, they are nothing but, I will assume x1 is equal to y. This is the first assumption I have made. Then what is x2? x2 is nothing but y dot and x3 is nothing but y double dot. So I have assumed the state variables y dot, y double dot. After assuming this is the first step. First we need to assume the state variables. After assuming this, we have to substitute the differential equation given in terms of state variables. So what I will do is, I will substitute x1, x2, x3 in this, I will call it as equation 1. So if I substitute this, d cube y by dt cube, y triple dot will be x3 dot plus 6 into d square y by dx square is y double dot 6x3 plus 11 x2 plus 6x1 will be equal to 2 into r of t. That means the given differential equation is transferred into a state equation. What is a state equation? X dot. I have to find out what is x1 dot, x2 dot and x3 dot. I will find out in a reverse fashion. First I will find out what is x3 dot. Since the differential equation is available here, I will send everything to the right hand side. I will write in terms of x1, x2 and x3. So first I will write x1 minus 6x1 minus 11x2 minus 6x3 plus 2 into r of t. This is the equation of x3. Then I will write x2. x2 dot. What is x2 dot? x2 dot is the differentiation of this. x2 dot will be equal to y double dot. y double dot is nothing but it is x3. So x2 dot is nothing but y double dot, that will be equal to x3. Then x1 dot is nothing but y. x1 dot is nothing but y dot is nothing but x2. So I have written this. So this in terms x2 dot will be equal to x3 and x1 dot will be equal to x2. So this, it is a general explanation. So what I have substituted the values. So first x1 dot is nothing but y dot, it is x2. x2 can be written as x1 dot. Then similarly x3 can be written as x3 is nothing but y double dot. So these are the state variables. I will write in the general form, I will write in terms of x1 dot, x2 dot, x3 dot. If you are using capital letters here, use capital letter here also. So basic representation is by using capital letters. So avoid small letters while writing the states. Better to use capital letters. Since I have written small letters here, I will carry the same thing. x1 dot, x2 dot, x3 dot. These are the state variables will be equal to. First I will write the equation of x1. x1 dot is having 0, 1, 0. Here there is only x2 terms. There is no x1 term as well as x3 term here. Then x2 dot only x3 terms 0, 0, 1. Then x3 dot he is having minus 6. All the terms, x1 term is 6, x2 term is 11, x3 term is minus 6. So this is the matrix A into x1, x2, x3 plus I have to write what is the matrix B. What is the matrix B? U terms. Where are the U terms here? Here there is no U term for x1 dot. There is no U term for x2 dot. There is a one U term. U means here it is R. There is one U terms in x3 0, 0, 2 into just one input. It is not U1, U2, U3. And remember, this is not U, this is R, because in the problem they have given R. So what is A here? This is a state equation. In state equation, A will be equal to 0, 1, 0, 0, 0, 1, minus 6, minus 11, minus 6. And what is B? B is 0, 0, 2. Then you have to find out another one, that is output equation, y is equal to cx plus du. Let output equation we will write what exactly is y. Where is y? Y is here. So y is equal to x1. Since there is only one term, that is x1, we can write y equal to 1, 0, 0 into x1, x2, x3. So this is the output equation. If we write C, what is C? 1, 0, 0. So A, B, C are the answers for this problem. So you have to find out what is the state model. You have written the state model, but the answer is A, B and C. Again I will rewrite what is A. Answers A will be equal to 0, 1, 0, 0, 0, 1, minus 6, minus 11, minus 6. What is B? B is 0, 0, 2. And what is C? 1, 0, 0. These are the state models for the given differential equation. The steps looks very complicated, but it is very easy. Just you have to assume only one thing, that is x1 is equal to y. Rest of the things, it is just a substitution. Let us solve second problem. Here the main intention is 10 u dot. This term is troubling. So what I will do is I will take this side y double dot minus 10 u dot plus 6 y dot plus 5y will be equal to u. So this term I will be substituting. So what I will do is I will take state variables. Assume state variables. So I'll be taking state variables. State variables are nothing but x1 is equal to y and x2 is equal to, x2 will be equal to, it is y dot minus 10 into u. So whenever if I differentiate this, I will get y double dot minus 10 u dot. Because of this whole term will get substituted. The same thing if you have any other inputs rather than u. If you, even the differential equation, if it is having u dot, u double dot, u triple dot, then the substitution should be like this. So let us substitute the values and we will check what it happens. Substitute x1 and x2 in differential equation. If I substitute this, so this is a differential equation, x2. Next, if I go for y double dot is nothing but x3. It is wrong. If you consider x3 will be equal to y double dot, then it is wrong, because the order of the differential equation is 2. You have only 2 state variables. There is no scope for adding x3. That is a very important thing. Don't get confused. So what we need to do is, we need to differentiate this. This is x2 dot. If I differentiate this, I will get y double dot minus 10u dot. So this is the substitution I will get. x2 dot plus, what is y dot? Y dot is 6 into x2 plus 10u. This is a substitution for y dot, plus 5 into x1 will be equal to u. So what is the equation for x2 dot? x2 dot will be equal to minus 5x1 minus 6x2. So already there is a u minus 60, it will be minus 59 into u. Then x1 dot, what is x1 dot? x1 dot will be equal to, it is y dot is nothing but x2 plus 10u. So in this problem, you will be having u terms in both the state variables. So I will represent that one. So x1 dot, x2 dot will be equal to, so in the x1 dot, you don't have x1 term, so 0. You have x2 term, that is 1. Again in x2 dot term, you have x1 term, it is 5, x2 term, it is 6 into x1, x2 plus, what is a b? B is nothing but u terms in x1 dot and x2 dot. So there is a u term in x1, it is 10, and there is a u term in x2, that is minus 59. So it is 10 and minus 59 u. Compulsorily for a and b, it should be a square bracket, and x1, x2, it will be a flower bracket. So these are the vectors. Vectors are represented in flower bracket. Matrix are represented in a square bracket. Then, so A will be equal to 0, 1, minus 5, minus 6. B will be equal to 10, minus 59. You have to find out what is C and D. What is C? I will write output equation. Y is equal to x1. Here I am having only x1 term. So no x2 term. 1, 0 into x1, x2. So C is 1, 0. If I write the answers, what is A? 0, 1, minus 5, minus 6. What is B? 10, minus 59. And what is C? 1, 0. Compulsory it should be a square bracket. So this is about problem number 2. Next, for easy understanding, so these two problems are very important. It will be asked, they can ask any data. The substitution is only the same procedure. Let us solve one more problem. I will write a system, obtain state model for mechanical system. So let us consider the case of spring mass damper system. Sometimes the question can be like this. In this type, you can take any of the systems. Either you can consider only spring mass system or you can consider spring mass damper system. Let us consider spring mass damper system. So this is a spring, a damper. The damping coefficient is C, the spring having stiffness K and mass having M. I will be assuming a displacement of mass, say it is Y. Let Y be the displacement of the mass. Because of the displacement, what happens? The system tends to oscillate. And also I will be, this force is subjected to this mass is subjected to a force F of t. So when you apply F of t, the system will get oscillate. Let us write a free body diagram. This is mass. Again, this is Y. The force should be in the direction of displacement. Rest of the things, it should be away from the X. So what is the force across the spring? Force across the spring is K into Y. Stiffness is force by deflection. Force is stiffness into deflection. So the direction should be away from Y because these two are the restoring forces for the mass. Then C X, C Y dot. See the variable and write. So according to Newton's second law of motion, summation of force will be equal to mass into acceleration. Here M is Y. M Y double dot will be equal to my F minus Y. F plus means it is acting towards the displacement, minus Cy minus Ky. Cy dot and Ky are acting away from the displacement. So what basically I am writing differential equation, My dot plus Cy dot plus Ky, this is equal to F. This is a governing differential equation for this system. In the previous cases they have given differential equation. Here you have to derive the differential equation. So I want Y dot here, Y double dot. So what I will do is, I will rewrite the differential equation, My double dot plus Cy dot plus Ky is equal to F. So this is nothing but F of t is the input and this is the Y. So divided by M, Y double dot plus C by M into Y dot plus K by M into Y, that is equal to F by M. Now it is a differential equation in terms of Y double dot. Assume the state variable. How many state variables assume? That depends upon the order of the differential equation. In the first problem, order was 3. You are assuming 3 state variables, x1, x2 and x3. Second problem, Y double dot. So only 2 state variables, x1 and x2. Here how much? Again 2. Let state variables be x1 is equal to y, x2 is equal to y dot. Again here no compensation, no f dot terms. If there is f dot terms, plan like this and substitute it. I will replace, that means substitute x1 and x2 in differential equation. If I substitute x1 and x2, y double dot is nothing but x2 dot x2 dot plus c by m into y dot. What is y dot? Y dot is nothing but x2 plus k into y is nothing but x1 will be equal to f by m. I will be rearranging this. x2 dot will be equal to minus k by m, sorry, this is k by m into x1 minus c by m into x2 plus f by m. This is x2 dot. What is x1 dot? So x1 dot is equal to y dot. Y dot is nothing but x2. So I got x1 dot and x2 dot. I will write the matrix. x1 dot, x2 dot will be equal to, what is x1 dot? x1 dot is having only one term, that is x2, so 0, 1. x2 dot is having both x1 term as well as x2 term into x1, x2 plus, what is B? B is a matrix which need to have input terms. So in the x2 there is no input terms, there is no u terms. So I will write 0. In the x2 dot I will be having input term, that is f by m. f by m x1, x2. So this is my A and this is matrix B. Then what is matrix C? So y is equal to x1, y is equal to x1, that is equal to 1, 0, 0, x1, x2. This is C. So if I want to write A is 0, 1 minus k by m minus c by m. What is B? 0 and f by m. What is C? 1, 0, 0. So this is the problem number 3. Most of the cases in the question they will be giving differential equation. You have to solve that. Let us solve the next problem. Next problem is they have given A, B and C. You have to find out what is the transfer function of the system. This application is there in the MATLAB. In the MATLAB also they have fetched the equation in terms of matrix, then transfer function is calculated. Let us calculate this, how to get a transfer function. Before that, what is transfer function? Transfer function for the input y of s by u of s will be equal to, we have derived in the previous class, it is nothing but bc into si minus a inverse plus d. So what is the inverse of the matrix? Inverse of the matrix is nothing but adjoint of si minus a divided by determinant si minus a plus d. So this is a formula to find out the transfer function of the state model. Let us calculate what is B, C and D first in the given question. That means you have to extract the values of B, C and D. This is in the form of x dot is equal to ax plus bu and y is equal to cx plus du, and after 1, 0 it should be x1, x2. There is no d term here. So this is in the form of, I will write that also, x dot will be equal to ax plus bu, y is equal to cx plus du. So this also you have to remember. I will extract the data. What is A? A is nothing but 0, 1, minus 2, minus 3. So x dot will be equal to ax plus bu. Then what is B? B is nothing but 2, 0. Then y is equal to cx plus du. There is no d term here. D is equal to 0. Only thing is c, 1, 0. First let us try to calculate What is this? Si minus A inverse. First I will be calculating the matrix S into I minus A. What is S into I? I is nothing but, it is an identity matrix. Identity matrix is nothing but 1, 0, 0, 1. This is an identity matrix. If you multiply by S, you will get Si. So S, it will be S 0, 0, S minus A. What is A? 0, 1, minus 2, minus 3. So calculate this Si minus A. Si minus A will be equal to S minus 0 is S, 0 minus 1, minus 1, 0 minus of minus 2, plus 2, S minus of minus 3, so S plus 3. This is Si minus A. But what we need? We need inverse. Si minus A inverse. Let us calculate Si minus A inverse. It will be equal to adjoint of Si minus A divided by determinant of Si minus A. First let us calculate what is the determinant. Determinant of Si minus A will be equal to S into S plus 3, multiply this, and there is a minus here, minus 1, 2. So it is plus 2. So it will be S square plus 3S plus 2. This is the Si minus A determinant. If I want to find out adjoint, so adjoint of any matrix A is nothing but transpose of cofactor matrix A. Let us calculate what is the cofactors here. Cofactor matrix of Si minus A will be equal to, first I have to consider the sign. I will rewrite this S minus 1, 2, S plus 3. This is plus minus. First, if I want to calculate it for S, I have to eliminate these two. What is the remaining here? It is S plus 3. Then if I want to calculate for the second element, minus will be there. I will put minus, then eliminate these two, then I will get minus 2. Then for the third element, yes, eliminate 2, plus, then it is minus, minus into minus, it is plus 1. Then for the last element, eliminate these two, this is yes. So this is cofactor matrix. But what is the transpose of cofactor matrix? Cofactor of Si minus A transpose S plus 3, 1, minus 2, yes. So this is a transpose of cofactor matrix, which is nothing but adjoint A. So if I write Si minus A inverse, therefore Si minus A inverse will be equal to adjoint A, this is a matrix, determinant 1 divided by S square plus 3S plus 2 into adjoint of A. Adjoint of A is S plus 3, 1, minus 2, yes. After finding out this, there is another shortcut for 2 cross 2 matrix in order to calculate A inverse. See here, S minus 1, 2, S plus 3. What you have to do is, first you have to replace the principal diagonal elements. What are the principal diagonal elements here? S and S plus 3. Replace this, S plus 3 and S you got. Then multiply negative sign for secondary diagonal. Multiply secondary diagonal, minus 1 into minus 1 plus 1, plus 2 into minus 1, minus 2. So this is a shortcut. Then after doing this, calculate transfer function. Transfer function y of s by u of s. Y of s divided by u of s will be equal to bc into si minus a inverse plus d. Here d will be equal to 0. So let us substitute the values of b and c here. B is nothing but 2, 0. C is 1, 0. and Si minus A inverse is S plus 3, 1 minus 2 and S. Let us multiply these two terms. First I will multiply S plus 3, 1 minus 2S into 2 and 0. 1, 0 I will keep it as it is. First I will multiply these two. S plus 3 into 2, it is 2 into S plus 3 plus 0. Then minus 2 into 2, 4 plus 0. So minus 4 plus 0. This is the multiplication for these two. And then 1 comma 0. Again 1 divided by S square plus 3S plus 2. Usually you will forget this term. It is very important. Here also the same thing. S square plus 3S plus 2. Just you will be taking this matrix. You will be forgetting this. So remember Si minus A determinant value. It is very important. So 1 divided by S square plus 3S plus 2. Then the last step what I need to do is I need to multiply this 1 into this plus 0. So 2 into S plus 3 divided by S square plus 3S plus 2. This is a transfer function for the given state model. So with this we completed the basic problems on state space variable characteristics. Thank you.